So when I am saying this constrained random stimulus, what this actually means, what this uh, implies, although you want the similar simulator to generate the stimulus, you don't want totally to make it automatic. Like you want to mention certain constraints here, like address is 32 bits, opcode maybe add sub or store, length might be less than 32 bytes. All those things you have to mention. Like you have to model all these things to make this consistent, not exactly random in all the cases. Like here you can see constrained random stimulus, like the way we have seen for direct testing. In constrained random stimulus, when you have whole design space, you have certain features and you might have some overlapping features as well, where you will not write tests again from scratch, you will use the existing ones, and this makes it very consistent. And you might sometimes, as I said, you might encounter certain new areas which you might not anticipate, and this helps in achieving good results than what we expected out of directed testing. So the basic idea here is, when you have constant random tests, it runs for certain number of seats and we check the functional coverage, identify if there were any holes kind of thing, holes in the sense any bugs kind of thing, and make some modifications which are required, and it's kind of iterative, and these things goes on adding constraints uh, and achieving good results when compared to the directed testing. So when it comes to verification, you need to randomize certain things. What basically randomization in terms of verification, this thing also we will be seeing in our lectures, upcoming lectures. So device configuration, environment configuration, input data need to be randomized, protocol exceptions, errors and violations, delays. I'll be talking about each of these things, why we have to randomize these things in our verification environment in little while, when we go into actual course. So as we talked about this constant random stimulus generation, one more important thing next to it is functional coverage. So why we need functional coverage is, it is basically like you add the code to test bench, monitor the stimulus going into the device like DOT, and its reaction and response to determine the functionality exercised. Let's say my DVD player has music system which is having throwing out certain songs, like it gives out certain songs or certain music. I monitor, monitor this particular the functionality in my device, and there might be certain functionalities, like there might be many such functionalities in my DVD. So I'll see whether I was able to see all those functionalities happening in the whole of my design verification. So feedback from functional coverage to stimulus, when you get continuous feedback, you will be able to approach to coverage, 100% coverage very quickly. If you are not able to give the feedback, that might be a bit harder, because what is going wrong you might not know. When you know what is going wrong, then only you can do corrections and you can make it work properly. So feedback is one such important thing in functional coverage to approach to 100% very quickly. So the next very important thing, we have seen that constant random stimulus generation. Second one is functional coverage. The third one is layered test bench. So this is one of the flat test bench that is created many times before in simple Verilog. To make things simple, this is generated in a simple Verilog. So here this drive the control bus is certain task which I can isolate from my whole of this code. So I have written separate task for this particular drive control bus. Now I need to just call write here. Like here I said task write. So if I have automated something like automated, isolated or automated this particular thing into a task, I can just call it wherever I require. So by that I can build a layered test bench which is creating like submodule kind of thing, where it will not make complex as we go into larger or complex designs. So physical and command layers is the first step to the layer test bench. We'll be seeing this layer test bench layer by layer. Like you have signal and command layers initially. Signals in the sense where this DUT lies, and this command is basically the driver drives these inputs to this design under test. And we have monitor where the actual results are monitored or something like observed in this scenario. So the next one is functional layer, where this functional layer added with feeds down into the command layer. The agent block receives higher level transactions such as DMA read or write, and breaks them into individual commands or transactions. These commands are also sent to the scoreboard that predicts the result of the transaction. The checker compares the commands from the monitor with those with the scoreboard. So the next one comes is scenario layer. In the scenario layer, like a the functional layer is driven by the generator in the scenario layer. This is the generator. Remember that your job is as a verification engineer is to make sure that the device accomplishes the intended task or not. Like an example device is this MP3 player that concurrently play music from its storage, download new music from host, and responds to the user inputs from the user, such as adjusting the volume and track controls and all those stuff. Each of this operation is a scenario now. Like downloading a music file from these might take some several steps, such as control register reads and writes to set up an operation, multiple DMA writes to transfer the song, and then another group of reads and writes need to be happened. Scenario layer of your test bench orchestrates all these steps with a constant random values, parameters such as track size, memory locations, and all those stuff. So basically scenario do such things, scenario layer. So the next one and the final one is this test layer and the functional coverage. The top level test is the conductor. Like he does not play any musical instruments but instead guides the efforts of others. The test contains the constraints to create the stimulus. This test contains all the constraints which are required to create the stimulus. And the functional coverage measures overall progress of the test in fulfilling the verification plan requirements, as we previously discussed. So this is overall picture or overall layers that were there in typical test bench